Hi guys. So we're 2 weeks to go until the Easter holidays, which puts us at lesson 1, week number 9. Only 2 lessons this week because we have Paddy's Day on Wednesday. So you'll have one video, which is today, and then you'll have your live one for the second one of the week. Okay, so week number 9, lesson number 1, and what I asked you to do at the end of last week was to do question 1 and 2 during the class time. So this was during lesson number 3. Okay, so I'm going to fly through questions 1 and number 2, and then I'm going to give you a couple to do, and I'm going to go down then, I'm going to do number 10 before we finish, so the most difficult one on the page I'm going to do for you, right? So let me correct number 1 and 2, then I'll go down and do number 10. So remember, we're dealing with all these graphs and linear patterns and non-linear patterns, and we're also bringing the word slope into things, and it's kind of got a bit confusing. So we'll take our time going through this, and if we get this done by the time we go back, I will be happy. Okay, so let's keep going and see how do question 1 and 2 to start. I'll do it for you. Okay, so what we have here is a taxi driver charges a fixed minimum and then a fee. You know, where you get into a taxi and it's always like €2 at the start, and then every kilometer you go, you pay. It goes up and up and up. Okay, so the graph shows the cost of hiring a taxi for journeys between 0 and 6 kilometers, between nothing and 6 kilometers. So we're going from 0 to 6. Come up there. Use your graph to answer the following questions. What type of pattern does this graph represent? And give a reason for your answer. Bear in mind, I've put the answers out here to questions 1 and 2 as well, so you can check them later on against what we do as we go through it. So, well, straight away, looking at that line there, it is a straight line, so it is going to be linear. So it's a linear pattern because it's a straight line. Why? Because it's a straight line. Let's see how much I can fit in here. So it's going to be a straight line, and if I look at the points in that line. So if I'm to have a look and I can say, right, well, here's 1 kilometer here. 1 kilometer was €5. 2 kilometers was €7. And I go from 3 kilometers is going to be €9. And 4 kilometers is going to be, €11. And 5 kilometers is going to be €13. And 6 kilometers is going to be €15. So you can see that going between this point and this point is you're adding £2. This point to this point, you're adding £2. This point to this point, you're adding £2. So you could say it's a linear line. So to answer the part A, well, it's linear because it's a straight line, but the common difference, the CD, is 2. So the common difference is always the same. So you know, for something to be linear, the common difference must be the same. Someone emailed me to ask me this one, so that's why you see rise, run, slope on the diagram. Find the slope of this line. So if I want to find the slope of that line, remember, I get the rise over the run. So what I did, I picked this point here and this point here, and I said, well, how much does it go up by? And it goes up by, so well, it starts off, this point here is at 9. And it goes up as far as 11, so the rise is going to be 2. Between the same 2 points, how far does it go over by? Well, it goes between 3 and 4. So the rise is going to be, the run is going to be 1. So remember, find the slope is a rise over the run. So it's rise over run, which is equal to 2 over 1. If I was to say, right, what if I didn't pick those 2 points? What if I picked the points up? What if I picked these points up here? Up in this area of the graph, and I said, right, okay, well, let's see, well, how much does it go up by between those 2 points? So between that point there and that point there, how much does it go up by? Well, it goes from here up, so it goes up between 13 and 15, so the rise is going to be 2. As it's going up, how far does it go over? Well, it goes over between 5 and 6, so it goes over that amount. So the run is going to be 1. So again, the slope is going to be 2 over 1. I could do that between any 2 points, and the slope is always going to be 2 over 1, 2 over 1, 2 over 1, every time. What does the slope represent in this context? So part C, what does the slope represent? Well, the slope in this context, represents the common difference. Because the common difference, 2 over 1, which is equal to 2. The way you could word it, the rate of change or rate of increase. I'll put it down 2 ways for you. And you can check the solutions on this as well. What did they say? What did they say it is? The first difference or the rate of change. They went exactly the same as I went. Okay. What is the y-intercept? So you remember on your graph that the y-axis is the wall. So the y-axis is this axis going down here. So where does the line intercept the y-axis? If we look at our graph, it intercepts it at this point here. That's where y comes into contact with the y-axis. So the answer to that one is just at €3. What does the y-intercept represent? So what does the y-intercept represent? So you think, what's happening at that, where the line touches the y-axis? Because it hasn't gone anywhere. Our distance is 0. So basically what that says, remember if you look back at the start of the question, you have a fixed minimum. So the y-intercept represents the fixed. How much the taxi's costing you before you even go anywhere. Part F, copy and complete the following table. So at 0, it was €3. See that here? At 1 is this point here. It was a fiver. At 2, remember it goes up by 2 every time. So it's 7, 9, 11, 13, and 15. So it goes up by 2 every time. Part G, John hires the taxi to take him from his home to the airport, a distance of 4.5 kilometers. How much would the taxi charge John? So we're thinking, right, 4.5 kilometers. So I go to my graph and I see, well, where along here is 4.5 kilometers? It's right here between 4 and 5, isn't it? 1, 2, right here between 4 and 5. See the dot going in there. So 4.5 kilometers. So what I do is I bring a line all the way up to my graph. When it hits the graph, I go in. My answer is going to be, it's going to cost me 12 quid. Okay, so it's going to be €12. And finally, Anne hired a taxi to take her from school to the nearest cinema. The taxi driver has charged Anne €21. How far, or what's the distance from Anne's school to the cinema? Right, where's €21? Oh, it's going to be higher. It's going to be off the charts, isn't it? It's not even going to be. It's not even going to be in our graph. So how far is it going to be? Right. Well, if we say 21, so €21, and we take away what's the standing charge, how much does it cost before you even move anywhere, is going to be €3. So the amount of kilometers she's going to have to pay for is going to come from 19 quid. It's going to come from €19. So this is your standing charge here. So I'm taking that away because that's what you pay before you go anywhere at all. And then you say, right, well, we know now that every kilometre you go, it costs you €2. So if it's costing her €19 travelling fee, well, it's going to be 19 divided by 2, which is what's 2 into 18 is 9. So it's going to cost her €9.50. Is that what the question asked? 9? No, what's the distance? So 9.5 kilometres. Not asking for euros. 9.5 kilometres. Okay, and as I said, you have the full question. Is that wrong? They're saying 18. Why are they saying that? So if we go back here, I'm after doing something wrong, am I? 21 minus 3 is not 19. 21 minus 3 is actually 18. So it's easy, even easier. 18 divided by 2, which is 9 kilometres. 21 minus 3 is 18, not 19. Okay, Any question that you can ask me. Question 2 then is here. Let's see how much I can squeeze into the box. The number of bacteria on a kitchen surface is estimated. The graph shows the estimated number of bacteria in thousands present on the kitchen surface each hour. How many bacteria were present on the kitchen surface initially? So initially means at the start. So at the start of our graph, here it is here. Oops, not there. Going over it. Let's go a bit bigger. At the start, we have 18,000. So 18, remember it's in thousands. So 18,000 at the start. Bacteria at the start. A name for this type of pattern. So what, remember we had linear and we had the other one. So is it a straight line? It's not. So the name of this pattern is a non-linear pattern. If you wrote quadratic, I'd give it to you because it's a curve. How many bacteria were present after 5 hours? So we say, right, 5 hours. Where's the time? Okay, our time is down here. We go to 5 hours, which is here. And we say, right, 5 hours. Like that. And go across. And again, we're at 18,000. Bacteria after 5 hours. So it kind of went up and then went back down as far as 18,000. A disinfectant was applied then, right? So after a disinfectant was applied at a certain time. If the bacteria was first counted at 8 a.m., what time do you think the disinfectant was applied? So if it was 8 a.m., so what they're saying is that this at the start is 8 a.m. What time do you think the disinfectant? So if they're saying the start is 8 a.m., this here is going to be 9 a.m., 10 a.m., 11 a.m., 12 p.m., 1 p.m., and 2 p.m. So whereabouts is when do you think that a bacteria? So if you look at the growth kind of going up and up and up and up and up and up and up, and then it starts to drop and drop and drop and drop and drop and drop. So where do we think the antibacterial was applied? So if we say, right, it's definitely not at 9 o'clock because we're still getting this upward thing. 10 o'clock, we're still kind of getting the upward thing. 11 o'clock, it's on its way down. So it's somewhere here, isn't it? That it starts to apply. So I don't know, about 10:30, somewhere around about this point here. Around about 10:30. Or, yeah, I would say about 10:30. It starts to drop. So as soon as the antibacterial is sprayed on, it starts to drop. I don't know what they give in the answer for that. Around 10:30, the population starts to decline. Okay, so okay, right. So what I've done is for you guys for tomorrow, I'll get rid of this so it's not confusing people. Up the top, I'll get rid of this here, so it's not confusing people. When you're working on this. So what I've done is, guys, I've given you these ones here. So this is your lesson 1 homework due for lesson 2. Oh, the questions have gone. Walkabouts. Okay, so I've given you question 3, question 5, question 6, so 3, 5, 6, and 9. That's all I've given you. So 3, 5, 6, and 9. I'll just write that in the box because it got deleted on me for some reason. So 3, 5, 6, and 9. So 4 questions. I'm going to do question 10 for you now. So 3, 5, 6, and 9. Okay, so there's your homework there. It's in the OneNote in case you're not sure. I've also highlighted the questions for you. They're based around what we're just doing. And I'm going to go right down to the bottom of this exercise and I'm going to do question number 10 for you now before we finish. Okay, just so you have the kind of the I suppose the last one, which is generally the most difficult one, done for you, and then you're doing the other 4 over the next while, okay, before our next class. So question 10. Mary is thinking of switching phones. Okay, so Mary is thinking of switching phones, which we all do. She's the choice of two, Talk and Walk or Fast Talk. So two different companies. This could be Air and this could be Vodafone or something like that. Talk and Walk charges 4 cents per minute. Okay, so I'll do that in blue. So this guy charges 4 cents per minute plus 20 cents for every call. The other company charges 8 cents a minute with no connection fee. Okay, so they're slightly more expensive per minute, but they've no connection fee or for calls. Complete the table below, which tells us the breakdown of the different prices. Okay, right. So, right, let's fill in. Let's do Talk and Walk first. Let's do the left column first. Right. So the connection fee for Talk and Walk is what is it? 20 cent. And then for every 4 cents per minute after that. So for 1 minute, it's going to be 4 cents and 8 cents. Okay, so 4 cents per minute is going to be 16 cents. Nope, not 16. 4, 8, 12, 16, 20, and 24 cents a minute. Okay, so that's Talk and Walk. Am I right there? Talk and Walk, 4 cents per minute plus 4 cents per minute. Okay, nope, that's wrong. I'm adding them up. I should be adding them on as opposed to putting them in separate. So what we're going to do is if we have 20 cents connection fee, then for 1 minute of calls, we'll add them up as opposed to putting them in separate. We'll have to add them at the end. 24. So I'm adding 4 to 20. Add another 4. Add another 4. Add another 4. Add another 4. And add another 4. That's easier. As opposed to me putting 4, 8, 12, 16, 20, because I'll have to add each time to the 20 at the end. So I'm just going to add them up as a total. The second one, Fast Talk, 8 cents per minute, but no connection fee. So this is why I had to go back on that last one, because they would look funny across if I had to add them up at the end. So no connection fee, and then you pay 8 cents a minute. So 8, 16, 24, 32, 40, and an 8 is 48. So that's 8 cents every time. Here I'm adding 4 on the left, Talk and Walk, I'm adding 4 cents. On the right, I'm adding 8 cents every time. Okay, so there's our table filled in. Now, what are they asking us to do? So over here on the left-hand side now. Okay, so our left-hand side says, copy the coordinate plane into your copybooks and plot the points from part A on it. Okay, so we'll start. I should have done them different colours now that I'm looking at it, but we'll start with I'll do Talk and Walk in black. So I'll do Talk and Walk is going to be black, and I'll do Fast Talk in pink. Okay, just to show the different ones. Right, so Talk and Walk. Well, let's start with Talk and Walk. So time in minutes is going to be at 0 time in minutes. We're going to be at, for Talk and Walk, we're already going to be at 20. Then it's going to go up to, after 1 minute, 24. So remember that I'm graphing this column here. And I'm after doing these backwards as well, haven't I? Oh, all over the place today. 24, then up as far as 28. After 4 minutes, it's going to be, after 3 minutes, it's going to be 32. After 4 minutes, it's going to be 36. Nice straight graph, isn't it? 40 and 44. So there's my graph. There's my graph done there. So I'm just going to switch those. So Talk and Walk is now pink, because I'm not doing them backwards. And what's the other one called? Fast Talk, FT, Fast Talk. It's going to be in black. So there's my first one graphed, right? Now I'm going to switch to my black pen and I'm going to graph this one here. This though starts off at no time, you're paying nothing. So you don't have any minutes, you don't pay a thing. Looks great, doesn't it? No connection fee, only 8 cents a minute. Or is it better to pay a connection fee and pay 4 cents? Well, that's what we're looking to find out. Next time you get your a new contract for your phone, you can work out the overall cost as opposed to the immediate cost. Then it goes, after a minute, you go to 8 cent. 2 minutes, you go to 16 cent. 3 minutes, you go to, where are we at? 3 minutes, 24. So 24. 4 minutes, you go to 32. 32 there. 5 minutes up to 40. So same point as here. And 6 minutes, you go to 48. There. Okay, so there is one line there. And the other one then is this line here. You can see where they cross there as well. How is the connection fee represented on the graph? Okay, so well, the connection fee is always at the start. So if our Fast Talk had no connection fee and our Talk and Walk had the 20 cent connection fee. Okay, so basically it's kind of asking, and we're asked what the y-intercept was. Now we're given a graph and saying, well, what does it represent? So the connection fee represents the y-intercept. So where the graph touches the intercept, like so. What does the slope represent? Okay, so the slope represents the slope of this line. So if you think, well, look at that black line, it has a really steep slope. The other line hasn't got that steep a slope. So basically, if I were to draw any line, that's really steep, that's not as steep, that's not steep at all. So the black line is much steeper than the other. And why is it steeper? It's steeper because of our table up here. So the steepness of the line represents the price of the call per minute. So the price of the call every minute. The price of the call for Fast Talk is much more expensive. It's twice as expensive, 8 cent, as opposed to 4 cent for the T&W Talk and Walk. How long is a call that costs the same using either company? So how long is a call that costs the same using either company? And we can see it there. Where is the cost the same? Here it is here, isn't it? In this space here. And what is the time of that call? It's going to be 5 minutes. 5 minutes. And how is that represented on the graph? At the point they intersect. So the points that the graphs intersect. Okay? If Mary takes on average 3 minutes per call, which company should she use? This is what company should she be using, right? So we say, right, well, let's go a different color pen. Here's 3 minutes here. Let's go up and see where it touches these graphs. Well, if you go up to the graph and where it touches the black line here, and where it touches the pink line here, and you go in, well, if you're using the black line, that's going to cost you somewhere between about 22 cent. If you're going with Talk and Walk, the pink line, that's going to cost you 32 cent. So you're saying, well, if she's making all her calls for 3 minutes in length, you're much better off going with Fast Talk. So Fast Talk, isn't it? Because it's going to cost much cheaper. Which phone company's graph is directly proportional? So which phone company's graph is directly proportional? So it goes up in a straight line through 0, 0. It's this one here, so it's going to be Fast Talk Black. So answer is Fast Talk, because it goes through 0, 0. And that's our 0, 0 point down here in the corner. That's 0, 0. And Shanae, okay, so that's the most difficult one, and you can, I'll put the solution up to that as well. We go through the solutions to these. Sorry, my screen is frozen there for a second. So we go through the solution. You have the solution there to question 10. Any question on that, you can just email me and ask me. And what you're doing then for the rest of the lesson and for to be uploaded to the homework section of your OneNote before our second lesson of the week, which should be a live lesson, is question 3, question 5, question 6, and question 9. So 3, 5, 6, and 9. Just make sure that's correct. 3, 5, 6, and 9. And make sure they're uploaded. Make sure you're trying these. We're nearly finished with patterns. We're nearly ready to move on. And once we correct these and make sure everyone's okay with these, I said an extra class maybe later in the week, maybe Thursday or Friday, for O'Connell and for O'Sullivan together. But I've had very little people email me, ask me for that. But if you do fancy that, let me know. And then our second class, then we're just going over the revision exercises from the top again, going through the different questions that cause people, just giving a second chance to have a go at some of these different graphs and patterns and so on. So I'll chat to you later on in the week. Give those a shot. Make sure you upload them. I'll finish the video on the homework, and I will chat to you in the week. But in the meantime, if anything comes up, any issues, let me know. Email me, and I will like I did there with question 1 and 2. I can stick an audio file in and direct you to that if you're struggling. But do attempt them. Lay the questions out. Have a go. If you get it wrong, you get it wrong. You can correct it the next time. But it's important that you're battling through these and keeping up to date for when we go back. But 2 more weeks. You've Wednesday off this week, and then we'll be back in the lab face to face. And we'll, this is much easier when I'm looking over your shoulder and we're doing them out in the board and in the classroom. Okay, mind yourselves. Have a good week. Talk to you later. Bye bye.